Hello, and welcome to the Pythagorean Identities Day 1 video. Now, in this video, we're going to be learning more than just the Pythagorean identities, but that's kind of the main focus. So let's start with just what is this unit, because it's a brand new unit. It's trig identities and proofs. So trig identities and proofs. Now, when I'm talking about proofs, I'm not talking about those like geometry proofs that you've done in the past. I'm talking about algebraic proofs. It's kind of like a puzzle. I give you the beginning, I give you the end, you have to tell me the middle. So first, let's start off with trig identities. What is an identity? Well, an identity, I'm going to underline that, is an equation or formula that is always true for any possible input. So we call something an identity if it's true for any possible input. And as you can see, we're working with our trig identities. So that's things like sine, cosine, tangent, stuff like that. So these identities, what do they mean? What is the statement that's always true? Well, today I'm going to be going over 11 identities with you. The first 8, you already know. So the first 6 are called the reciprocal identities. Or the reciprocal identities. Now, these reciprocal identities, some of these things you may already know. So if we're talking about sine of theta, I go, okay, well, what's the reciprocal of sine? Oh, that's cosecant of theta, because cosecant of theta is 1 over sine of theta. That's a reciprocal identity. But I leave sine of theta there because sine of theta is also the reciprocal of cosecant. So we can say that sine is equal. I'm sorry, that keeps happening. I'm not sure why. I think it's just because I wasn't in the pen. There we go. Sine is equal to 1 over cosecant of theta. So that's a reciprocal as well, just like with cosine and secant. So what's the reciprocal of cosine? Oh, that's going to be secant of theta, because secant of theta is 1 over cosine of theta. But we can also say that cosine is 1 over secant of theta. They are reciprocals of each other. The last 2 reciprocal identities you may be able to guess. The first one is tangent of theta. The second one is cotangent of theta. So we know that cotangent of theta is 1 over tangent of theta. We can also say that tangent of theta is 1 over cotangent of theta. So this is really cool because out of our 11 identities that we're talking about today, here is 6 of them. Here are 6 of our reciprocal identities, and these are ones that you already know. And another really cool thing about these identities is, like, if you were to take one of them, like just tangent of theta is equal to 1 over cotangent of theta, and square it, the same thing also is true. So if we said that tangent squared of theta, we can say that's equal to 1 over cotangent squared theta. Now, notice when I am squaring this, I'm putting the squared not on the outside over here. That's going to mean something different. We're putting it in between the function or the identity and the input here. So make sure you put that squared right there in the middle. So there's the first 6 identities. The next 2, again, you're already going to know. Those are called the quotient identities. So the quotient identities, remember, quotient is the answer that you get when you divide something. So if we're to find quotient identity for tangent, well, tangent is equal to 2 things divided by each other. Let's say sine and cosine. So tangent of theta is equal to sine of theta over cosine of theta. And our other quotient identity is that cotangent of theta is equal to cosine of theta over sine of theta. So again, these are all identities because no matter what we put for the input, these statements will always be true. So hopefully not too much. Make sure you write this down. Now let's get into those Pythagorean identities. So for the Pythagorean identities, we have to go back to a circle. We're not going to be looking at circles too much during this unit, but we do have to for a little bit. So for the Pythagorean identities, I'm going to shorten identities to IDS because identities is just kind of a long word. So for the Pythagorean identities, let's take a look again at a circle. So I'm not even going to call this the unit circle, just because we're just going to say that this radius is r. So if I pick a radius, there we go, it's going to be the point xy with our radius here. We're going to have an angle, it's called theta, where this is our x and this is our y. So just a reminder kind of where like y sine is the y value and y cosine is the x value, is that we say, oh, well, sine of some angle is opposite over hypotenuse. In this case, the opposite is y and the hypotenuse is r. So we got that sine is y by just multiplying r on both sides. We'll have r sine of theta is equal to y. And then for cosine, cosine was adjacent over hypotenuse. So our adjacent in this case is x over r. We multiply r to both sides. And we get r times cosine is equal to x. So for the unit circle, r is 1. And we're actually, I guess we're going to be using our unit circle. We're going to be carrying this through the next piece. Now, I say Pythagorean identity, but that's probably not the first thing you've heard of. The Pythagorean theorem is something that we know. So let's go over the Pythagorean theorem really quick. So our Pythagorean theorem, in case you have forgotten, is a squared plus b squared is equal to c squared, where a and b are legs of a triangle and c is your hypotenuse. Now it's not just of any triangle, it's of a right triangle. And it's very lucky for us that if we head back to our circle, we have already created a right triangle there. But instead of using a, b, and c, we have the side lengths of x, y, and r. So we'll have x squared plus y squared is equal to r squared. But again, we know x, y, and r. So if we call this the unit circle, we're going to say that r is just 1, so this will be 1 squared. We know that x is our cosine value, so we're going to write cosine squared theta, so remember put the squared in the middle, plus our y value, or sine squared theta. We're not putting r in front of those because, again, we're assuming r is 1. So this first thing we have right here, our first Pythagorean identity is cosine squared theta plus sine squared theta is equal to, we can just write 1 because 1 squared is 1. So this is our first of our Pythagorean identities, and this comes from the Pythagorean theorem. So if you know your Pythagorean theorem, you can recreate your first Pythagorean identity. Now, here's something that I want to point out. As we go through and we work with these, you may not see this identity in this exact format. So you may see a variation of this. Like if we were to subtract cosine squared on both sides, we'd have sine squared theta is equal to 1 minus cosine squared theta. This is just a rearrangement of the Pythagorean identity, and this also happens to be true. Another rearrangement might be if you subtracted sine squared on both sides. So having cosine squared theta is equal to 1 minus sine squared theta. So that might be something else that you see as we go through and do our work. I'll talk about what that work is in just a second, because we have 2 more Pythagorean identities to figure out. Now, that first Pythagorean identity is going to be really, really important to us. So what if I took that first Pythagorean identity, so cosine squared theta plus sine squared theta is equal to 1. What if, just for fun, I divided everything by sine squared theta? Okay, so I've divided everything by sine squared theta. Well, this first piece here, cosine squared theta divided by sine squared theta. Let's see, cosine divided by sine, that's cotangent. So this would be cotangent squared theta. Remember, the square has to come along for the right. Plus sine squared theta over sine squared theta, anything divided by itself is just 1. And 1 over sine, or 1 over sine squared, is going to be cosecant squared theta. So this is our second Pythagorean identity. Cotangent squared theta plus 1 is equal to cosecant squared theta. And again, you might see rearrangements of these. So if we were to subtract cotangent squared on both sides, you might see 1 is equal to cosecant squared theta minus cotangent squared theta. Or instead, if we were to subtract 1 on both sides, you might see that cotangent squared theta is equal to cosecant squared theta minus 1. So this is our second Pythagorean identity. Our third Pythagorean identity comes from the first one again. So if we write down cosine squared theta is equal to 1. And this time, instead of dividing everything by sine squared, what if I just divided everything by cosine squared? So if I divide everything by cosine squared, well then, let's see, cosine squared divided by cosine squared, anything divided by itself is just 1. Sine squared theta over cosine squared theta is going to give us tangent squared theta. And 1 over cosine squared theta is going to be secant squared theta. So this is the third of our Pythagorean identities, and then once again you may see rearrangements. So if we were to subtract 1 on both sides, you may have tangent squared theta is equal to secant squared theta minus 1. Or if we were to subtract tangent squared theta on both sides, you might see 1 is equal to secant squared theta minus tangent squared theta. So all the ones we have here in black, those are the ones you're going to need to know. The blues are just rearrangements. But again, if you can't think of some of them, as long as you know that first Pythagorean identity, cosine squared plus sine squared is equal to 1, you can find out the rest. So I've been mentioning these identities and their works, but what is this work that we're talking about? Well, those are the proofs that I referenced at the beginning of the video. So I'm going to go through 2 proofs with you and kind of talk about what that looks like, and then I'll have you go to the Go Formative and work on a few on your own. As we go through the first example, I'm just going to clear this away completely. As we go through the first example, I'm going to be doing all the work on the left side of the screen, and then on the right side of the screen, I'm going to be giving you strategies that you can use. So our first example that we'll have is secant squared of theta minus 1 over secant squared theta is equal to sine squared theta. Now, I'm giving you the beginning, I'm giving you the end. It's your job to tell me how these two things are equal or why they are equal to each other. That's the thing that we're trying to prove. So if you think about this as, okay, I'm going to, make this argument to you. This is our hypothesis. So I'm giving you a hypothesis that these things are true. I'm going to tell you right now, I'm never going to give you anything that's not true. So the hypothesis is always going to be true. So these two things are equal to each other, but I want to know why or how. So it's up to you to show me how or why using our identities as well as your algebra skills. So when we start off with a problem like this, it's probably going to be easier to take something really long and complicated and simplify it down than to take something that's like, oh, this looks pretty nice, and expand it out to this. So I always pick my complicated side first. So I'm going to start with this side. So I'm going to say, okay, secant squared theta minus 1 over secant squared theta. Okay, so I look at this and I'm like, I have to simplify this somehow. Something I cannot do, that some of you are going to want to do, is cancel out the secant squareds. You cannot do that because of this -1. So if it's a fraction, I usually look at my numerator, look at my denominator, see what I can do. And a strategy I'm going to give you, write this off to the side. If something is squared and there's a 1, it's probably, a Pythagorean, there we go, identity. So if there's something squared and with a 1, it's probably a Pythagorean identity, because the Pythagorean identities only work when it's squared. If you don't have anything squared, it's not going to work. And I see here we have a secant squared and a 1, so it's probably a Pythagorean identity or a arrangement of my Pythagorean identity. So if I go back and look at my notes, I see, hey, this is an arrangement or rearrangement of that third Pythagorean identity. And we can say that secant squared minus 1 is equal to tangent squared theta. And that denominator stayed the same. So we were able to take a moment and say, okay, so this first part here that was part of our hypothesis is equal to tangent squared theta over secant squared theta. So I take a look at this and I go, oh, this doesn't look familiar to me. So I'm going to separate this out and have this become, oops, that's still a laser pointer, there we go, and have this become tangent squared theta times 1 over secant squared theta. So as I'm showing my work, now that I've kind of established we're moving over here, I'm going to work, and keep working until I get to sine squared theta. So I've separated out my fraction. I go, okay, tangent squared theta, 1 over secant squared theta. That seems familiar. So more hints on the side. After you've figured out things with your Pythagorean identities, if you can change anything to sine or cosine, that's going to make things a lot easier. So let's change everything to sine of theta and cosine of theta, because we know that everything can be changed to sine of theta and cosine of theta, and if we do that, things are probably going to cancel. So if we change tangent squared theta into sine and cosine, we're going to get sine squared theta over cosine squared theta. Those squares have to come along for the ride. And then if we change 1 over secant squared theta, well, that's one of our reciprocal identities, and this becomes cosine squared theta. I take a look at this and I go, you know what? I got cosine squared theta in my denominator, and I'm multiplying by cosine squared theta, so I'm going to cancel those out, and I'm going to be left with sine squared theta, which, look, is what we were looking for in the first place. Yay! We were able to prove that secant squared theta minus 1 over secant squared theta, we're able to use our skills, our identity skills, and get all the way down to sine squared theta. But the way to celebrate is if we have a hypothesis, our proof, we now have to write a conclusion. So lastly, make sure you write a conclusion. And it's going to start with 3 little dots in a triangle formation. These 3 little dots mean therefore. Therefore, you repeat your hypothesis again. So therefore, secant squared theta minus 1 over secant squared theta is equal to sine squared theta. So you have your hypothesis, you prove it, you have your conclusion. Make sure you're showing me your work. This is the most important part here. So let's try one more example. So for my second example, we're going to have 2 secant squared theta is equal to 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta. Okay, so again, we have to pick which side we start with. Both of these things are equal to each other, so you get to pick whichever side you want. If you pick a side and get stuck, you're totally allowed to just give up and go to the other side. That's perfectly fine. So both of these look fairly complicated, but I'm like, ooh, these fractions look intimidating, but it's probably going to be easier to simplify these fractions down to this than to take this piece and expand it out. So I'm going to start with my right side and go, okay, I've got 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta. I need that to be equal to something. Okay, problem here. First thing I try to go to is if it's got a 1 and is it squared, probably Pythagorean identities. Well, I see 1s, but I don't see any squareds. Now, again, Pythagorean identities do not work if it's not squared, so can't use that. Next strategy was change everything to sine or cosine. Okay, we're already there. So my last strategy for you, algebra. You gotta know, you gotta have strong algebra skills, in this case, fractions. So I take a look here and I go, oh, you know what? I have two fractions that I'm trying to add together. I need to have common denominators. So I'm gonna multiply this left side over here by 1 plus sine of theta, top and bottom. And on my left side, pardon me, on my right side, I'm going to multiply by 1 minus sine of theta, top and bottom. So once I do that, let's see, in my numerator, I'm going to have 1 plus sine of theta over, let's see, the denominator. When I multiply 1 plus sine of theta times 1 minus sine of theta, I'm going to get 1 minus sine squared theta, because that's the difference of squares. Then it's going to be plus 1 minus sine of theta in my numerator over 1 minus sine squared theta. And again, I get that by multiplying those denominators together. So now that I'm here, okay, awesome, we have common denominators, so I can add these together. So I have 1 plus sine of theta plus 1 minus sine of theta over 1 minus sine squared theta. So let's see, I look at that numerator and I go, okay, I have a sine of theta and a minus sine of theta. Those can cancel out. And I got a 1 and a 1 giving me a 2. So this is going to be 2 over 1 minus sine squared theta. Now, if you ever feel like you're stuck, it's okay to go back to your hypothesis or your original problem and see if you're on the right track. So for instance, I see we have a 2 up here, which feels kind of weird, but I also say that my answer is supposed to have a 2 in it. So, okay, I know I'm on the right track. So I get to here, like, okay, I don't think there's anything algebra I can do. Everything's in sine or cosine, but I do see something with a 1 and with a squared. I'm going to use one of my Pythagorean identities. So 1 minus sine squared theta is a rearrangement of our very first Pythagorean identity. And it's in fact going to be cosine squared theta. So this is going to be 2 over cosine squared theta. Okay, so I'm getting really, really close to my final answer. I'm going to go back and take a look. I see I'm supposed to end up with a secant squared. Well, I have a cosine squared, and I know that those two things are related. So if I separate this out, I'm going to move this up just a little bit. If I separate this out into 2 times 1 over cosine squared theta, because that's what that means, well, I know that 1 over cosine squared theta, that's a reciprocal identity. And it ends up becoming 2 times secant squared theta, which is exactly what I wanted. That's my answer. So we did it. We've used our Pythagorean identities, our reciprocal identities, and algebra to get to our final answer. So again, you can't end here. We have to write our conclusion. And our conclusion is that now that we've shown all this, therefore, we just kind of rewrite the hypothesis. 2 secant squared theta is equal to 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta. So this is one of those things, the more you practice, the easier it will get. There are some more problems for you to do in the Go formative that we'll be working on tomorrow. Please let me know if we have any questions, and I will see you then.